All right, have your homework handouts out. Should look something like this. So hold it up so I can see that it is completed. And not empty still like it was when I gave it to you. Excellent. All right, let's go ahead and take a look at these together. Number one, you should have gotten 3 different answers since it's a cubic equation. Abby, what did you get?
0, 4, negative 1.
0, 4, and negative 1 is correct. Number 2, what did you get for your 4 answers in this quartic equation? Brandon?
Positive negative 3i and positive negative 2.
Good. Positive negative 3i and positive negative 2. Number 3, what did you get for your answer here, Maddie?
No solution.
No solution. Now, you should have had 2 roots, but they were both extraneous. What 2 roots did you initially find?
2401 and 81.
Good. 2,401 and 81, but they were both extraneous. Nothing checked. No solution. Number 4, what did you get for your answer here? Audrey? Audrey? I could get over the intercom or something. Go, Audrey? What did you get at?
67 and negative 61.
67 and negative 61. Brecken's like playing with something's wrong with my audio. Number 5. So 67, negative 61 were the answers to 4. Number 5, what do we get? Genesis? 1 is correct. Number 6, we should have gotten initially 4 possible answers, but what answer or answers ended up checking out, Kendall?
4 and 5.
I did not get the 4 checking out. I only had a 5. So my negative 4 was extraneous, my 4 was extraneous, my 1, 5 was a duplicate. I only had 5 checking out. We may take a look at that here in just a moment, but just looking at the right-hand side, filling in the 4 times 4 is 16, minus 20 is a negative 4. I know absolute value can't be a negative, so that's why the 4 would not check. Number 7, what did you get for your 3 answers to this one? Michael?
I got 5, negative 3, and positive 3.
Not quite what I had. Brandon?
That's what I had. Positive negative 3i.
Oh, positive negative 3i. Did you say I?
No.
Okay, yeah, 3i, negative 3i, and 5 should have been the answers. And number 8, for redemption, what were your answers to number 8, Michael?
Negative 1, 6, and negative 4.
The negative 1, 6, and negative 4. All right, that gives us the answers. Now let's go over the ones that we struggled with. So I'm just going to go one at a time. If everyone's perfect, we won't bother. But if anyone missed something or needs to see it work, I'm willing to work all 8 if we need to. We've got time for that. That's not a problem. We're about to take a quiz that's going to look a lot like this. So if any of these gave you trouble, let me know. Let's start with number 1. Did anyone have issues with number 1? All right, so we're all good here. Gavin Brecken, if you did, reach out to me because we're not wasting time on the video now. All right, number 2. Any issues there? All right, let's take a look at that one. First thing we want to do with the equation is set an equal class to 0. So I'm going to leave my highest power positive, bring the negative 5m over, 5m squared rather, as a positive, bring the 36 over as a negative, all equal to 0. So far, so good? Or is that like right up front, we were already on the wrong track? So far, so good. All right, from here then, we want to do what once we've set it to 0, class? Factor it, right? So we're going to do our 2 sets of parentheses. The m to the 4th should split into
M squared.
signs. And then the 36, it can't be 6 and 6 because that outer inner would cancel, but to get a 5, we would need 9 and 4. So we want the 9 to be the positive, the 4 to be the negative, and then we set these equal to 0. I get little mini quadratics. M squared is negative 9, m squared is 4. Then we have to do what, Genesis? And that's where we get the positive negative 3i because we're taking the square root of a negative, and then positive negative 2 as we take the square roots of 4. You could use the formula here, but you would say m squared equals. And then for the negative b, that would be a negative 5 plus or minus the square root of b squared, which is 25 minus 4 times 1 times negative 36 would make this a positive now. 144, or subtracting the negative 144 all over 2a. 25 plus 144 is 169. Square root of 169 is 13. You get negative 5 plus or minus 13 all over 2. And that's where you would also end up with a negative 9, well, negative 18 divided by 2, negative 9. Positive 8 divided by 2 is 4. equal to m squared. Still have to take those square roots. Get these 4 answers. Does that clear it up here? Again, I'm not a big fan of the formula method. On this one, factoring to me is a lot easier, but it can work as long as you remember it's not x, but x squared, or in this case, m squared. We good to go now? Any other questions on number 2? Or does anyone say, can we work another one like number 2? Would anyone like to practice one like number 2 before the quiz? Or you feel like, oh, I'm ready now. All right, number 3, with the rational exponents. Anyone need to see that one worked out or want to practice one like it? Number 4, binomial raised to a rational power. And with the binomial raised to a rational power, need to see that one worked.
Real quick, so
Yeah.
the denominator is the root and then the
Correct.
numerator is the square.
Right, so when we raise it to the 3/2 power, that's the square root raised then to the 3rd power. So power over root, the square root of 16, well really positive -4, right? And then we're going to turn it around and cube it, and that's where we get the 64, and then we brought that 3 over to the positive. Right, good question. Good. Any other questions on 4? All right, number 5, very similar to number 4, but any questions on 5? Notice number 5, we don't have a positive negative because it was an odd denominator, so an odd root. Where number 4, we had the even denominator, or even root, which did give us the positive negative. Questions 5. Number 6, with absolute value. Anyone need to see the absolute value worked out? All right, number 7. This one, you could do the P over Q thing, but it factored by grouping. How many saw that you could factor by grouping? How many did P over Q and are now mad? All right. Yeah, you could pull out an x squared, leaves you with x -5. You pull out a positive 9, leaves you with x -5. And so you end up with x -5 times x squared plus 9. And there's your 5. And x squared is -9, so that's where the positive -3i comes from. Really quick and easy. Unless you do the P over Q, because then you're trying 1, -1, 3, -3, 5 finally works. And so you have to go through several lists before you get to that. But, people are looking at Maddie like somehow she's to blame for your misfortune.
She asked me why was mine so short. She was trying to criticize me.
Oh, you did the grouping. Oh, okay, so so you're laughing at Maddie because Maddie
Yes.
didn't do the grouping. Oh, okay, I got you now. I thought you were looking at her like it's your fault somehow. Okay, gotcha. No, you're good. You're okay. You're with the cool crowd, and then and then Maddie is like, Maddie, can you come over and play? No, I'm still working on my algebra homework. Y'all don't play anymore. You're too old and sophisticated to go play, right? No, you do. No, you're not old.
Legos.
No.
Well, yeah. Legos.
Yeah.
Cool. Okay, all right.
Pillow fort.
Yeah, my oldest is about to turn 7, so I don't know like at what age you're too cool to never
No.
take
They make
it.
that
Go
age
to her house
between
and sit on our
13 and
phones.
14, or 12
Yeah.
and 14, where they don't like playing, but then
And then they get over and they realize I'm missing out on the best part of life. I'm gonna have fun.
Yes.
Yeah. How many were that way in junior high? You're like, I'm supposed to be cool and cool people don't do this. And you're like, forget being cool. I'm just gonna have fun.
Yeah.
Yeah. It took me till my junior year of high school, and I'm like, forget this. I'm just gonna have fun. And junior and senior year were great. The other years, not so much. All right. Anyway, questions on 7. All right, number 8, unfortunately, you did have to do the PQ thing, but you should have gotten on the second try if you did 1, then -1. Now, if you decide I'm going to do all my positives first, well, you go through 1, 2, 3, 4 before you finally get to 6. So it just depends. Any questions, number 8? Do we need to see it worked out? That's what we just been working on yesterday. Would you want to see that one?
Well, for my answer, I had -6 and 4. So I did it backwards.
Oh, okay, let's take a look then. So you found that the -1 was the root that checked, right? You got your possible roots, you found the -1 checked. You put the -1 in the half box, and you did the synthetic division, right? So you brought down, you multiplied, you added, you multiplied, you added, you multiplied, you added. Okay, we're still on the right track. You plugged in your x squared and your x, and then you backwards FOILed. Right here is probably where the mistake happened. You know signs have to be different, but to get the -2, we need the 6 to be the negative in here, and the 4 to be the positive in here. But when you set them equal to 0, it becomes +6 and -4. Did you do the correct factoring, or was it wrong outer inner?
I did the right factoring.
Factoring was right. You just forgot that these are set equal to 0, and that's how we get the root. So yeah, so if negative 1's the root, the factor is x plus 1. So literally, these are the factors of the polynomial, but your answers are negative 1, negative 4, and positive 6. Okay, great question. Good. Any other questions on 8? Are there any problems, last call, on here?
It's a sign.
It didn't touch you, so no paper cuts, no assault. All right, or battery, whatever that is. Battery's what's in the remote that runs the projector. All right. Okay, all right. Anyway, stop. Stay. Any questions on any of these, or you want to work another one of these before I hand you a quiz that looks a lot like this?
It's exactly the same.
All right. How many of you were perfect on the homework? Wow, we got a couple perfect people over here. How many went 7 for 8? You just missed 1. All right, fantastic. And the one that we missed, we got. All right, so this quiz I'm about to give you, not this quiz, but the quiz I'm about to give you, it doesn't frighten you. No.
We'll see.
All right, clear your desk except for a clean sheet of paper. And Brecken's like, I'm scared. I can't hear you, Brecken. All right. All right, clear your desk except for a clean sheet of paper, pencil, calculator, eraser, extra lead, whatever else. First last name at the top of your paper, along with today's date, which is something. 12/3/21. That's what it is. 1, 2, 3, 2, 1. Don't get it backwards. 12/3/21 is today's date. This is quiz 17 that we're taking. Quiz 17. So they're not the exact same problems from the handout, lest you were thinking that. And there are only 7 of them, not 8. But very straightforward. Solve them. And I give you 2.
I don't have a person behind me.
You can take them both.
Do I get a quiz?
No.
Was that where my second one ended up? Yeah. You don't get one. You just give you the time off. We'll just give you a 0 and let you take a break. Just kidding. All right. Solve for x. Be sure you check your answers in problems where it's applicable to make sure that you're not including extraneous roots in there. All right. And Gavin and Brecken, we'll keep the video running here so that way you kind of get an idea of how much time they have. Obviously, you can pause the video if necessary, but we'll keep it rolling. just a few more minutes to be finishing up. Keep that work covered with your quiz copy as you can. When you're finished, you can sit there, work on something else, rest your head. As they say in elementary school, hide your eyes. You remember when that was like the worst punishment ever? Hide your eyes. I was like, I'd love to hide my eyes for just a few minutes. Just about one more minute remaining. All right. Well, we'll go ahead and take a look at those on Monday as we prepare for our test. For now, wanted to go over some problems with you that I pointed out to you yesterday. If you want to copy this down in your notes, it's not a cubic, it's a quartic. But it's going to solve the same way, and really no matter how high you go with an equation of higher powers, anytime it's not in a quadratic form, you can always use the P over Q method. Again, I'm going to do more of a mental list at this point, but what's always the first root we try, class? Positive 1. So let's start with a positive 1. If it doesn't work, what do we try?
Negative 1.
Always negative 1. Now, after that, if it's an even number, you could try positive negative 2. If it's an odd number, maybe a positive negative 3, but I'm just going to kind of go through these mentally. I know the 1s, the 2s, the 3s, the 4s, they're all available to me from the 24 over 1. So we plug in the 1 to the 4th. 1 cubed times 2. 1 squared times negative 13. 1 times negative 14. And plus 24, yes or no, equals 0.
Yeah.
Hey, I like that. Doesn't always work out that nice, but there we go. On the first try, so once we've established our root, by the way, what's the factor that would give us a 1? X minus 1 is a factor, 1's the root, 1 is what we're going to put in the half box. And so, let's write down the coefficients. You're doing this with me here. And we'll do our synthetic division. And if you're like, hey, this sounds like kind of what I did on the quiz, that's a good indicator. Now what here, Audrey?
You bring down the 1, and then you multiply with 1, 3, negative 10, negative 25, positive 24.
Oh, careful.
Yeah, negative 25 and 0.
All right. And of course, we got to plug in our letters, right? So what letters should go in here, Abby?
X to the third.
Well, you're reading off your own paper too. That's fine.
X to the third, then X to the X squared, and then X and then nothing.
Right. And if this were a quadratic, we would factor or use the formula. But it's not quadratic, is it? So as I told you, kind of alluded to this yesterday, if it doesn't turn into a quadratic, you got to go through the process again. Now here's the good news. This number will still be the same, maybe a different SIG, a different sign. This is negative, it was positive, but it's still the 24. So my P over Q values are the same as they were before. The 1s, the 2s, the 3s, the 4s. I've already tried 1. There is a chance there could be another root of 1. So let's give that a try. And we're basing it now off of this polynomial. The x cubed plus 3x squared minus 10x minus 24. I wish I could keep going down the page like you can. I've got to go over here. So let's try the 1. And of course, if we plug in a 1, my numbers are going to be...
1, 30, negative 30,
And is that going to equal 0?
No.
Not even close. Okay, let's try negative 1. Okay, now put in a negative 1. All the odd power signs are going to change. So this becomes... negative 1, but this is going to stay a positive 3. This is going to become a positive 10 from the negative times negative. This is going to stay a negative 24. Does that equal 0?
No.
All right, so then since 1 and negative 1 didn't work, class, let's go to
Negative 2.
negative 2. I'm just going to go, I'll take the order I was going to go. I'm just going to try 2 next. All right, so we cube the 2. We square the 2 times 3. We 2 times negative 10. And of course we have this negative 24 at the end. No, and Brandon may have been a step ahead, which is why I didn't suggest the 2. All right, we'll try the negative 2. He's like, I already tried it, it don't work. But we had to find out for ourselves. All right, let's try the negative 2. Cube the negative 2. Negative 8. Of course, this is going to stay the positive 12. This is going to change to a positive 20. And of course, this is going to stay a negative 24. Again, there's that shortcut I was mentioning yesterday. Does that come out to 0? So there's our next root. So we know one factor is x minus 1. We know another factor, class, is going to be... well, that's the root, so x plus 2 is the factor. But I'm going to take the root, negative 2, put that in the half box, and we'll copy these, because again, this is now the polynomial we're working on. This one has been reduced down to this. We'll put our 1, positive 3, negative 10, negative 24 next to it, and do this synthetic division. Michael?
You pull down the 1, then you get -2. You pull down a 1, and you get -2. You get -12, +24, 0.
All right, now at this point, when I put in my letters, Kendall,
1x squared, 1x, hang on.
now it's quadratic. So now I'm either able to factor or use the formula. So Genesis, what are you thinking on this polynomial we're left with? Factor or formula? All right, well, let's try factoring it. The x squared, the negative, and the 12.
4 and 3.
Does the outer inner check? All right, so the original polynomial then has a factor of x minus 1, x plus 2, x plus 4, and x negative 3. So, to what does x equal, class?
1, -2, 3, and 4.
There we go. 1, -2, 3, and -4 are the 4 roots of this polynomial equation. By the way, you notice we essentially factored this. It's kind of an awkward way to factor something, but it works. And again, it would be a pain, but if this had a 5th power leading power, p over q once, p over q twice, that would get you down to cubic, p over q a 3rd time before you finally get to quadratic. But it's just a sustainable, repeatable model. Now, for your sanity's sake, I'm not going to go higher than 4th powers, okay? But by then you understand the process anyway, right? Of how you could theoretically, not sure when you'd ever have to do it, but there's some like 6th power equation. Well, this is how you'd end up solving it, working your way down. Questions on this? I'm going to see how that makes pretty logical sense. It's a bit of a pain, but it makes logical sense. Let's try one together. Number 42 on page 128. Turn your textbooks, you go to page 128. By the way, on one hand, someone might look at the problem we just worked and say, well, yeah, we kind of got lucky, though, because the 1 worked right off the bat. Well, here's the nice thing. Remember, listen, if the 1 doesn't work up front, it's not going to work the next time. So whatever numbers don't work, let's say you go 1, -1, 2, -2, 3 finally works. Well, the next time around, we're not even going to try those numbers that didn't work, because if they don't work the first time, they're not roots of the original polynomial. They're not going to be in there at all. Does that make sense? So you don't have to retry things that have failed, which is a nice feature. All right, number 28, there on page 1. Try that around. 42 on page 128. I'm dyslexic there. We've got a c to the 4th, -2c cubed, -19c squared, +32c, +48 equals 0. I'm not going to make a list, but class, we can tell just looking at it, what are my possible rational roots here?
1,
Positive -1.
+-2, +-3, +-4.
Yeah, and that's probably plenty, right? If it takes us past those 8, we're in real trouble. But yeah, +-1, 2, 3, 4, they're all there for us. So let's start with the
+1.
+1. Why not? Because if it works, then we use it. If it doesn't work, we rule it out for the rest of the problem. So we plug in the 1. What should I write down here, Maddie? And does it work?
No.
Okay, so how about -1? What should I write down, Maddie?
+1, -2.
Well, you're cubing the -1. Also remember, if it's an odd root, or an odd power, it's going to change the sign when you go from a 1 to a negative. So,
+19.
well, this one's an even, so it changes this back to a positive times the negative stays negative. So this one's, because of the even power, stays the same. Odd power changes. Even power stays the same. But here, the -1 gives you the, because the odd power changes. And then here's a nothing, so it just stays. All right. I'm talking not just to Maddie, but to all of you. Do you see how that's going to really help you? So you can try a 1 and a -1 without having to do a lot of extra math. 2 and -2, you do the math once, but the next time you just find where are my odd powers, change those, my even powers, leave them. This one looks like it's going to be close. Yeah, this one works. Y'all with me there? All right, so if we were writing the factors, x plus 1 is the factor, but in the half box goes the -1. And Brandon, help us with the synthetic division as you do it there on your paper. Kind of tell us what you're writing down.
Bring down the 1 to get 1, and then 1 multiply to get negative 1, then add to get negative 3, then multiply to get positive 3, then add to get negative 16, then multiply to get positive 16, and add to get 48, and then multiply to get negative 48.
All right. And of course, we're going to fill in the gaps here with what, Kendall?
X cubed.
Well,
C cubed.
yeah.
C squared, C, and then
All right. I'm going to recopy this off to the side just because I can't work my way down like you can on your paper. All right. Now, do I need to try 1 again, class? No, I done tried it. It don't work. I could try negative 1 again if anyone feels like, hey, maybe there's 2x plus 1 factors. Anyone want to try it a second time? Now we've moved on from that. We're ready for a change. All right, so let's try 2. All right, what do we write down for our 2? And let's go to Audrey.
8 minus 12 minus 32 plus 48 equals 0.
All right, is that a true statement? No. All right, so now class we try negative 2. And that's going to change a couple of things. How should I write this down now, Audrey?
Negative 8, negative 12, positive 32, positive 48 equals 0.
There we go. The 2 odd powers change the signs. The even powers leave them alone. Does that equal 0, class? All right, so now we try 3. And let's give Michael this opportunity.
27, negative 27. Then you got negative 48, positive 48.
All right, does that work?
Yes.
I don't think there's ever been such an obvious time that it works. This really worked out great. You know what I just realized? You know why it works so great?
There's 3.
You could factor this by grouping. Now we could, I wasn't actually planning for this. I was planning just to keep going here. I'm like, wait, there's a shortcut. I love shortcuts. We could go through and do the synthetic division with the 3, right? And, we could do all of that. 0? Negative 16, negative 48. And when we plug it in, we end up with a 1c squared negative 16, which could backwards FOIL into...
C positive 4, C negative 3.
And that really didn't take that long, but we could factor this by grouping. C squared, C negative 3, negative 16, C negative 3. And there's our C negative 3 and the C squared negative 16, which becomes C plus 4, C minus 4. So what are my 4 roots? There's a factor. There's a factor. There are factors. What are my 4 roots, class?
Negative 1, 3, positive 4. Yeah.
There we go. Negative 1, 3, positive 4, negative 4. Questions on this? All right, that one I wasn't expecting the sum and difference. I also wasn't expecting the grouping. You can tell it's been a little while since I worked this problem. All right, questions on that? But hey, just something to watch for, right? 41. I doubt 41 works the same way, so probably 41 will give us a regular run through. And this time I'm going to be watching for grouping though, just in case. Because I don't like doing the PQ thing if I can group. Right, Maddie? Genesis be all like, All right, copy down number 41. And for Kendall's sake, it's a good thing there's X's in this one. Confuses us with other letters. Oh, I do see some. No, never mind. I didn't look at it close enough. I started saying, oh, it's all positives. If it were, it's not. Okay, I spoke to you saying, if it were all positives, that tells me something about my X values.
It's negative.
You would have to be a negative, because there's no way you're plugging in positives and it's equal to 0. So I wouldn't even bother with positive 1, positive 2. Would I use 3 here, class? Now I do 1s, 2s, 4s, 5s, and hopefully it's going to fall into one of those, right? But because there is a negative there, okay, I can't gamble that it's all negatives. All right, so let's start by trying
Positive 1.
positive 1. And Genesis, what do I write down?
1, 10, 27, 2, negative
And does that add up to 0?
Yes.
First try, look at that. All right, so in the half box, we put the 1, and next to it, we actually write down what we just wrote down. And since Genesis was deprived of a chance to really do much, we'll let Genesis take the synthetic division.
1, 11, 11, 38, 38, 40, 40, 0.
All right. And of course, we'll fill in the gaps.
X cubed squared, X gone.
Any grouping here? No, not this time. All right. Now here, I spoke too soon, and I didn't even realize it. Now, do you notice we do have just positives? So for the rest of the way, I am not trying any more positive values. And notice it's still the 40s, so it's still, 1 we've already tried. But we can try negatives of 1, 2, 4, 5. So let's start by trying now, Brandon. Negative 1? All right, tell me what to write.
Negative 1. Positive 11. Negative 3. Positive 4.
And does that equal 0? All right, so now let's try. Negative 2. We're not trying any positives because anything you plug in that's a positive is going to leave it all positive, and you can't add a bunch of positives and equal 0. We need some of this alternating stuff. All right, so let's try the negative 2.
Negative 8. Positive 44. Negative 76.
Good job.
And positive 4.
All right, does that equal 0? Yes. Okay, so there's our next one. So we found a 1 right up front. We've got a negative 2 here. We're going to put the negative 2 in the half box. And 1 plus 11 plus 38 plus 40. All right, walk me through this part here, Abby.
You bring down the 1, multiply by 2 for negative 2, and then positive 9, negative 8, 2, and then positive 20, and then negative 40.
And of course 0, of course we'll plug in the, let's see, we left off here.
X squared, X, and then gone.
All right, and it looks like we can factor this, which is really nice. Factors easily into anyone.
5 and 4.
X plus 4, X plus 5. We already know that one of our factors is an X positive 2, and a factor is an X negative 1. Do we have to write these? No. I just like to show it because I'm a nerd. What are our other answers? We got a 1, we got a negative 2 class. Negative 4, and negative 5. 1, 2, 3, 4 roots in our quartic. Questions on this? All right, tonight for homework, you're going to do one like this. You're going to do page 128, number 39. In addition, you're going to do a handout that has 2 word problems on it. So it's a short little handout, but these word problems are similar to what you'll see on the test on Tuesday in lesson 78. So if you're watching on YouTube, find the handout in the description of the video, or a link to the handout in the description of the video. Those in the classroom, I would recommend, there's plenty of room on here to solve the word problems right on the handout. And then on the back side of the handout, I would do number 39. That way it's all together on one paper. But for homework, page 128, number 39, do this handout. Monday, we will take a look at your quizzes off camera. We will review for the test, and then Tuesday is your test on lots and lots of different types of equations and stuff. If you want to know page numbers, just a reminder, pages 118 to 137 are the pages for this test. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.